Assalamu alaikum. So welcome to Ismail Academy. Today we're going to do some review for Calculus 2. So this is just introduction review for Calculus 2. So you're going to do integration, so especially substitution. And this is a good review for Calculus 1 when people want to take the final. Alright, let's start with the first question. So the first question asks me to integrate 16x dx over square root of 8x squared plus 1. So when you have a fraction, always what you do, take the expression on the denominator, do the derivative, and see if it's going to give you the top one, and vice versa. You do the same thing for the numerator to see if it's going to give you the denominator. So the one that should give you the other one is the thing that we need to substitute with. So for example, if I take the derivative of 16x, it gives me 16. I don't have 16 here, but if I take the derivative of 8x squared plus 1, it will give me 16x. That means this will be my u. So u will be 8x squared plus 1. So then du will be 16x dx. So as you see here, if I substitute back my 16x dx by du, here it will be u. Now this is the same thing as the integral of u to the minus half u. So here I'm going to use the power formula for integration. So if I have the integral of u to the n du is 1 over n plus 1 u to the n plus 1 plus c. So I'm going to use that idea here. So here it will be 1 over minus half plus 1 u to the minus half plus 1 plus c. So this is going to give me 2 because 1 over half is 2, u to the half plus c. Then I substitute u by its value, so we end up having 2 square root of 8x squared plus 1 plus c, and this will be your answer. Here they ask me to integrate 1 over 1 plus cosine x dx. So when you have this type of expression, and there is no way I can find out which one I need to substitute, so what you do, multiply by the conjugate of the denominator. So this will work most of the time. So here I will do what? I will multiply by the conjugate. So 1 plus cosine x, but to multiply by the conjugate of the denominator, I need to do it on both sides because I don't want to change the question. So I just multiply here by 1. So this will give me 1 minus cosine square, 1 minus cosine x over 1 minus cosine square x dx, and we know that 1 minus cosine square is sine square. So because 1 is equal to cosine square plus sine square, so 1 minus cosine square is sine square. So keep in mind the formula, the trig formula. Alright, so here I will end up having the integral of 1 over sine square x. This is minus cosine x. I will do that step later on. Now I split the denominator, so it's become 1 over sine square x minus the integral of cosine x over sine x dx, and here dx. So this is cosecant square x dx minus, and here we have cosine x over sine square x dx. As you see here, if I take the derivative of sine, it will give me cosine. So here my u will be sine x, so du will be cosine x. So here cosecant square is the ontological derivative of negative cotangent. So here I will have negative cotangent of x minus the integral of du over u square. So here is the same thing if I have minus cotangent x minus the integral of u to the minus 2 du. So I do the same thing using that formula. So I will have minus cotangent x minus, so it's going to be u to the minus 2 plus 1 over minus 2 plus 1 plus c. So here it's going to be the same thing as cotangent x. This is minus 1 and minus become positive. So u to the minus 1 plus c, so which is 1 over u. 1 over u in fact is 1 over sine. So it's going to be minus cotangent x plus 1 over sine x plus c. You can change it to cosecant if you want. It's up to you. So I can do it here again. Minus cotangent x plus cosecant x plus c. So here's the same thing. It's up to you to choose which one you like to put. Next question. So here we have integral 3 cosine x dx over square root of 1 plus 3 sine x. So again, I do the same thing I did in the previous question. I take the derivative of the numerator, see if it's going to give me the numerator. So 1 plus 3 sine, 1 is 0, 3 sine, that means 3 is constant, so I'll just take the derivative of sine, which is cosine. So that means I will have 3 cosine. So u will be 1 plus 3 sine x. So du will be 3 cosine x dx. So here it's straightforward, so I will have the integral of du over square root of u, which is the same thing we did previously, so the same thing as u to the minus half du, so which is 2 u to the half plus c, so it's going to be just 2 square root of 1 plus 3 sine x plus c. Here is the same thing again. You see we did the conjugate, and by the way, can we do it in different way? Yes, we can do conjugate. We're gonna do it in two way here. Let me use the conjugate, and I use to transform cosecant to sine, because this is the way that most of students do it. So they transform cosecant to sine, and they deal with the sine set to deal with cosecant. So let me start with that way, then I will do the conjugate and see what we will get behind that. So here I will have the integral of 1 over 1 minus 1 over sine, and here I will make common denominator, so it's going to be 1 over sine x minus 1 over sine x dx. So I multiply with the reciprocal, so it's going to be the integral of sine x over sine x minus 1 dx. You see, if I substitute here sine x by u, I will have cosine, but I don't have cosine here. So what I need to do here, let me create cosine first. I need cosine, so I don't have cosine here. So what I do here, I'm trying to let me split this one out, make it more simpler. So this is going to be sine x, I'm going to add 0, so minus 1 plus 1 over sine x minus 1. So in that case I will have sine x minus 1 over sine x minus 1 plus, so this is going to be dx, and I will have 1 over plus the integral of 1 over sine x minus 1 dx. So if I have here plus 1, so here it will be plus 1 minus 1. So it's based on what do you have, you choose the order of minus 1 plus 1. But keep in mind that we always have a 0 here. And we always have a 1 here. That 1 you can change it in any way you want. 2 over 2, 3 over 3, x over x, any form you want, but use the number that you need or the expression that you need. That means don't just like throw any two number and you make them equal. Like here, if I throw minus 2, 2, it's not going to help me in any way. So I have to throw a number that I need. So here I need 1, so I'm going to put minus 1, 1. If it was plus here, I will put 1, minus 1. So here, so this is just 1, so it's going to be just 1. So dx plus, and here I will talk about the conjugate is the same as we did in previous question. You see here we got 1 over 1 plus cosine. I do the same thing here. So what I do here, I multiply by the conjugate. So they're going to be 1 plus sine x over sine x minus 1 times sine x plus 1, because sine x plus 1 is the same thing as 1 plus sine x, because addition is commutative. So don't say, oh, they're not the same. So, but we cannot do it with the minus, because minus is not commutative. So I cannot commute the terms unless if it's addition or multiplication, but we cannot commute the terms with subtraction and division. So keep this one in mind. Alright, so now here I will have sine square minus 1, which is minus cosine square. So here it's just x plus the integral of 1 plus sine x over sine square x minus 1 dx, which is the same thing as x plus the integral of 1 plus sine x over minus cosine square x dx. It's not cosine square, it's minus, because sine square x is 1 minus cosine square x. So if I multiply here, I flip the idea. So cosine square x is 1 minus sine square x. So if I multiply here by minus, you see, I will have this minus 1. So now I can put out this minus out. So here it become x minus, and I split the integral, so it's going to be 1 over cosine square x, and here if I use positive, so I need to do parentheses, but because minus, if I multiply minus with the numerator, it's going to be minus minus both, so we're going to put minus here, put the x first. It's going to be sine x over cosine square x dx. As you see here, this is secant square, so the antiderivative secant square is tangent, and here we do substitution, so u will be cosine, so u is cosine, so du will be sine dx. So here I will end up having, let me take this spot here, so here I will have x minus the integral of secant square x dx, and if I substitute here, so I will have the integral of du over u square. So here the antiderivative secant is tangent, so it's going to be tangent minus, and here will be u to the minus 2 plus 1 over minus 2 plus 1 plus c. So here it's minus 1, this is minus 1, so it's become positive here. Oh, but there's one thing which is we miss here. Look, the derivative of cosine is negative sine, so that means I will have here minus du will be sine x dx. So that means here I will have minus du, that means this minus will become positive. You see, you have to be careful, guys. So, and I have to be careful. So this will be positive. Now I will have here u to the minus 1 over minus 1. So it's going to be x minus tangent x minus 1 over u plus c. And u is cosine. So the final answer will be x minus tangent x minus 1 over cosine, which is secant, plus c, and this will be your answer. So be careful, the derivative of cosine is negative sine, it's not sine. So now if I want to use the conjugate, so suppose I want to use the conjugate. So if I have the integral of 1 over 1 minus cosecant x dx, so if I multiply the conjugate here, I will end up having what? I will have 1 plus cosecant x over 1 minus cosecant x times 1 plus cosecant x dx. So if I multiply those two, I will end up having 1 plus cosecant x over 1 minus cosecant square x, and this is, we know that cotangent square x plus 1 is cosecant square x, which means that if I switch this here, I move this one here, so I will have 1 minus cosecant square x will be minus cotangent square x. So here it will become the integral of 1 plus cosecant x over minus cotangent square x dx. So here is the same thing, so I'm going to split the denominator, so it's going to be minus 1 over cotangent square x dx plus, or minus, sorry, because I have a minus on the denominator, so it's going to be minus again the integral of cosecant x over cotangent square x dx. So 1 over cotangent is tangent, so it's going to be minus tangent square x dx minus the integral of cosecant x over cotangent x dx. So we know that tangent square x is secant square x minus 1, so this will be minus, parentheses, the integral of secant square x minus 1 dx minus, and cosecant here, so it's going to be integral of cosecant x over cotangent square x dx. So here if I distribute, so it's going to give me the integral of dx minus the integral of secant square x dx minus the integral of cosecant x over cotangent square x dx, and this is going to give me what we call it tangent. This is just x. Okay, so let's deal with this form. So we know that cosecant x over cotangent square x is the same thing if I have cosecant x times tangent square x, which is the same thing as 1 over sine x times sine x over cosine x square square. So if I simplify the sine, I will have sine x over cosine square x. So here is the same thing if I have x minus tangent x minus the integral of sine x over cosine square x dx, and here I use u substitution, which is what we did before. So I put u is my cosine, so du will be minus sine x dx. So as you see, I will end up having the same answer, so it's going to be x minus tangent x minus 1 over cosine x plus c, and this is what I will get at the end, which is the same thing what we got before. So because we end up having these steps, and these steps we already did, we already know how to do this. Alright, so we did 2 ways now, so for that question. So as long as you know the properties, so the trig property, trust me, you can do any question, but keep in mind those properties are very, very important and very, very helpful. Alright, here, so here I choose 2x plus 1, so I will do this as my derivative. It will give me 2, so u will be 2x plus 1, so du will be 2 dx. So what I have here, I have 2 times 2 dx over 1 plus 2x plus 1 square. Now this 2 dx is my du, so it's going to be, and I pull out the 2 out, it's going to be 2 tangent integral of du over 1 plus u square. So this is tangent inverse of u, because if I have the integral of du over a square plus u square, so is 1 over a, I believe tangent inverse of u over a plus c. So this is how to deal with that type of question. So here my a is 1, so it's going to be just tangent inverse of u, so it's going to be 2 tangent inverse of u plus c, and u is 2x plus 1, so it's going to be just 2 tangent inverse of 2x plus 1 plus c. So, but sometimes they don't give you like a perfect square. For example, they can give you the integral of du over 3 plus u square. So keep in mind that this 3 in fact is du over square root of 3 square plus u square. So this is exactly how you should see it, because this is the square of a number. So which number is this? Is the square root of that number. If you make a square, give you 3. So to apply this, you need to transform this to square root, then apply this formula. So keep in mind, so that type of way. Alright, for here, so if I take the derivative of the denominator, so if I have x plus 4x ln 2x, if I take it prime, so it's going to give me 1 plus, here I have product rule. So it's not gonna work here. So let me take only the let me simplify this first. Let me take x as common factor. Alright, so here if I take so this is the same thing if I have ln x dx over x times 1 plus 4 ln square x. Alright, so if I take this one as my u, let me take a derivative of this one first, plus 4 ln squared x, so it's going to give me, this is 0 gone, so this is 0, so it's going to be 8, and derivative of ln is 1 over x, and ln x, so it's going to be 8 ln x over x, so I have ln x over x, so then this will be my u. I don't have 8, but 8 is there, so I don't need to look for 8 because I already have it already. So this is the same thing if I have 1. You see I have 1, so this is why I told you 1 and 0 sum are very important. So this is 1 ln x dx over x times 1 plus 4 ln squared x. So like I say here, I need to have 8, so what I do, I transform the 1 to 8 over 8. So now I put my u, so u will be 1 plus 4 ln squared x, so du will be 8 ln x over x dx, and this is what we have in here. So this is the top bar with the x on the denominator, so it's going to be 1 over 8 du over u, which is 1 over 8 ln absolute value of u plus c. So this is the antiderivative of du over u. So this will be 1 over 8 ln, substitute back, 1 plus 4 ln square x plus c. We know that 1 is positive, ln square is positive, 4 is positive, that means the whole thing is positive. So I don't need to have absolute value, so I will take it off and I put parentheses. So it's going to be ln of 1 plus 4 ln square x plus c. If this is not always positive, so keep the absolute value. Alright, so next question. So here we have cotangent 3 plus ln x over x. So cotangent in fact is cosine over sine, so it's going to be cosine of 3 plus ln x over x sine of 3 plus ln x. This is exactly how I transform it. Then if I take a derivative of sine, it will give me cosine, but what about the x? So let's do the derivative of sine 3 plus ln x. So like I say, we're going to use chain rule, so it's going to be 3 plus ln x prime. times cosine of 3 plus ln x. So this is 1 over x because this is 0. So I will have cosine of 3 plus ln x, the whole thing over x. This will be my derivative, so this will be my u. Sine is my u. So now let me take off this. So I put u equal sine of 3 plus ln x. So du will be 1 over x. So it's going to be 1 over x cosine of 3 plus ln x dx. So now I have dx with the cosine, so this with dx and x. So this means this form is my du. You see, this is my du. So then I will have du over u, which is ln absolute value of u plus c. So u is sine, so it's going to be ln of sine of 3 plus ln. You see, there's a mistake I made here. It was absolute value and I take it off. I change it to parentheses. Normally I should keep the absolute value. Why I keep the absolute value? Because sine can be positive, can be negative. So we need to have anything inside log should be positive. So be careful with this. Here if I take a derivative of sine is cosine. You see derivative of sine is cosine. If I take a derivative of cosine is negative sine, I don't have negative here, so I have only sine. So that means I will choose my u is sine of v. So du will be cosine of v dv. So the 3 is just a constant, so we're going to pull it out. So it's going to be 3 the integral of u to the half du. So which means that I will have 3 times u to the 1 half plus 1, so half plus 1 over half plus 1 plus c. So this is going to be 3 times here u to the 3 half over 3 half, which is 2 thirds. If I time it here, it's going to be 2 thirds, which means I will cancel the 3 plus c. So that's my answer will be 2, which is 2 sine v to the 3 half plus c, or you can do it as 2 square root of sine cube v plus c. So any form you want is correct. So here I will split the denominator. So it doesn't mean I will make the x by itself and the 1 by itself. No, I will split the denominator here because I have a 0 on the top and I have plus 1 here. I cannot substitute x plus 1. So what I do here, I add a 0 here, and the 0 I will make it equal to 1 minus 1. You see, I don't do it minus 1 plus 1. I do it as 1 minus 1. Why? Because I have a plus 1 on the denominator, and this is where I need to deal with that question. So here it's going to be x plus 1 over x plus 1, so I split the denominator. Dx minus 1 over x plus 1 dx. So this is just 1, so it's going to be dx minus, and the derivative here of x plus 1 is 1, so that means my u will be x plus 1, so du will be just dx. So then here will be du over u. So here is going to be 1 minus ln of absolute value of u plus c, and u is x plus 1, and you'll be done. I cannot take off the parentheses because I don't know what's the sign and the value of x. It may be positive, it may be negative, so I keep the absolute value. As long as you're not sure if it's going to be always positive, so keep the absolute value. Alright. Okay, so this is the answer here. Let's move to the next question. So here we have dx over square root of x times square root of x plus 1. So if I take the derivative of square root of x plus 1 prime will give me 1 over 2 square root of x. So Then I will choose, this is going to be my u, so u will be square root of x plus 1, so du will be dx over 2 square root of x, and this will be my du. So but I don't have a 2 here, but like I say, we can create the 2. So it's going to be 2 square root of x square root of x plus 1. Don't FOIL here, because when you FOIL, you just can take you away from the right direction. So here, as you see, this is my du, this is my u, so it's going to be 2 the integral of du over u. So it's going to be 2 ln u plus c, and u is square root of x plus 1, so it's going to be 2 ln absolute value square root of x plus 1 plus c. Square root is positive, 1 is positive, the sum is positive, so I don't need absolute value, so it's going to be 2 ln absolute parentheses square root of x plus 1 plus c, and this will be your answer. For next question, so if I multiply by the conjugate, I will have secant square minus tangent square, and I believe let's do this with that idea. So if I have 1 over secant theta plus tan theta d theta, so if I multiply by the conjugate on the top and the bottom, I will have secant theta minus tan theta over secant theta plus tan theta minus times secant theta minus tan theta d theta. So here we have secant square minus tangent square, so this will be secant theta minus tangent theta over secant square minus tangent square theta. So we know that tangent square theta plus 1 equals secant square theta, which means if I subtract tangent, 1 will be equal to secant square minus tangent square. That means this is just 1, I don't need it here. So I will end up having the integral of secant theta minus tangent theta d theta. So the entire derivative of secant is ln secant plus tangent, and here I will have sine over cosine, so I'm going to use substitution here. So this is going to be, let me spread the integral, so secant theta d theta minus the integral of sine theta over cosine theta d theta. So here I use my u will be my cosine theta, so du will be minus sine theta d theta. So here I will have minus here, so it's going to be plus du over u, and this will be ln, so it's going to be ln of secant theta plus tan theta. So you can do this in 2 steps. Multiply both sides by this expression, multiply both sides because this is over 1. So if I multiply this expression with this, I will have secant square plus tangent secant over secant plus tangent. Then you take this as your u, because when you multiply both sides, you're going to end up having the derivative of the denominator on the numerator. So then you're going to end up having du over u. Then you're going to end up having this expression. So it's like you do in this way. Let me put it in other color here. You will see the idea. So for here, I will have the integral of secant theta times times secant theta times secant theta plus tangent theta over secant theta plus tangent theta. This will be your u. So if I distribute here, I will have secant square theta plus secant theta tan theta, and this will be secant theta plus tan theta. If I take the derivative of tangent, it will give me secant square. If I take the derivative of secant, it will give me secant tan. So if I take the derivative of this one, it will give me that one. That's mean, in fact, it's like I'm having u prime over u, which is, if I integrate, is going to be ln of absolute value of u. So that's the idea, which is you're going to end up having ln of the denominator. So this is exactly how we deal with that way. So, but most of the time they give it to you as a formula. So here it's become minus the integral of du or plus du over u plus c. So, and my final answer, so I will write it here. So it's going to be ln absolute value of secant theta plus tangent theta plus, and this will be ln of u, absolute value, and u is cosine, so it's going to be plus ln of absolute value of u, which is cosine plus c, and this will be my answer for that question. So I hope it's clear. So let's move on to the next question. So here I prefer always not to deal with that type of form. I use always exponential. So when we have a f of x, change it to e to the f of x ln of a, it's more easier. So 2 to the ln of x in fact is e to the ln of x times ln of 2, which is the same thing as, because this is x ln of 2, you see it becomes just regular monomial. So this will be the same thing as the integral of x ln of 2 over x dx. So same base, subtract the denominator, the power of the exponent. It's going to be x ln of 2 minus 1 dx. So to integrate, I just need to add 1 divided by the term plus 1, or the exponent plus 1. So it's going to be x ln of 2 minus 1 plus 1 over ln of 2 minus 1 plus 1 plus c. So this is gone, this is gone. It's going to be x ln of 2 plus c. You can transform this back to its original form, which is the same thing as 2 plus c. And this will be your answer here. Alright, for this question here, when you have this type of question, try to get off the square root from the side. So I need to see how can I use the property of cosine to get off the square root. So what we know that cosine 2 theta is 2 cosine square of theta minus 1. So this is one of the property using cosine. So which means that if I have that's mean if I substitute this by x, that means this will be x over 2. So that means I will have cosine of x will be 2 cosine square of x over 2 minus 1. And this is what I'm going to use here, because I have cosine x, I change it to this form. I didn't substitute here because I will not change the boundary, because I just use the formula to transform cosine x to a similar expression. I didn't do substitution here. I just transform cosine to another equal expression. So this will be 0 to pi. So I will not touch the boundary because I didn't do any substitution yet. So square root of 1 minus, and I will put this to cosine square x over 2, and here will be positive 1 because I have a minus. That means if I multiply here by minus, I need to multiply the whole thing by minus, so this will be negative and this will be positive. So over 2 dx, which is the same thing as 0 to pi. So 2 minus 2 cosine square x over 2 dx. Take 2 as common factor. Don't just cancel the 2 here. No. Take 2 as common factor first. 2 times 1 minus cosine square x over 2 over 2. Now both of them can be cancelled out. So this is 1 minus cosine square. 1 minus cosine square is sine square. So I will change it to square root of sine square x over 2. The whole thing over the 2 counts, so it's going to be just dx. This is under 1 square root, so this is what we can simplify. If they're not under the same square root, we cannot do it. Alright, so I need to correct my writing here. All of them under the same square root. So here the 2 cancel out, so I don't have no denominator here. So we know that sine square, square root of something square, is the absolute value. It's not just you take off both of them. You don't just cancel like that and end up having sine x over 2. Don't do that. So when we have absolute square root of something square, is always absolute value of that thing. The only time we cancel and we move on is when we have absolute square root of something and the whole thing square. Then yes, we can cancel and get the inside. But when you have this, always pull out the absolute value out, because the square will hide the sign of the inside. If this is negative, the square make it positive. If it's positive, it stays positive. This is why we need to pull out the absolute value, because square root is always positive. So if this is negative and you just cancel without putting the absolute value, it's like you assume that the square root is negative. So please, when you have this expression, change it to absolute value. Don't change it to the expression inside of the square root. Alright, so here I will end up having absolute value sine. So I will end up between 0 and 2 pi absolute value of sine of x over 2 dx. Now I'm going to substitute, so u will be x over 2, so du will be dx over 2, so that means I will have 2 du will be dx. Now I need to change the boundary. When we substitute this value to change the boundary, when u equals 0, when x equals 0, u will be 0, and when x equals 2 pi, u will be equal pi. So just put 2 pi here, you're going to have 2 pi over 2, so it's going to be just pi. And here will be absolute value of sine of u times 2 du. We know that sine on the first and second quadrant is positive, always positive. That's mean between 0 and pi, the sine is always positive. So this is the sine, and this is the cosine, and here is your pi, this is 0. You see between here and here, you see the sine is positive between 1 and 0. So I don't need to have absolute value here, just need to take it off because it's always positive. Alright, so here is the same thing. If I have the integral between 0 and pi of sine of u, I put the 2 here, du, which is what is the antiderivative of sine is negative cosine. So if you forgot this idea, so pull out the circle. So here this is your sine, cosine, negative sine, negative cosine. Derivative of sine clockwise is derivative. Counterclockwise is integral. The antiderivative of cosine is sine, the antiderivative of sine is negative cosine, and so on. So I hope it's clear. So here I will have 2 times minus sine of u between 0 and pi, so which is going to be 2 times, and we have minus sine of pi minus minus, so it's going to be positive sine of 0, so it's going to be 2, which is going to be 1 plus 1. There we go. You see what they did here? So this should be cosine. What I'm doing here, I'm integrating, so I'm keeping the same expression. Alright, so it's going to be cosine, cosine, so it's going to be 1 here, because cosine of pi is negative 1, so minus pi is going to be positive, and this is 1, so the answer will be 4. So I hope it's clear, and be careful again. So you see, I already know the answer, but you see when we wrote it in different forms, so that means keep in mind and let your eye open. Alright, so next question here. So here the derivative of cotangent is cosecant square, so it's straightforward here, so I use u equal cotangent of y, so du will be cosecant square of y dy, so here I will have the integral of u cube du, so this is my du, so which is going to be 1 over 4 u to the 4 plus c, and just need to substitute here. This is straightforward, so 1 over 4 cotangent 4 of y plus c. So here I'm going to use a double angle formula, the same thing we did in the previous question. So we know that cosine 2x is 2 cosine square x minus minus 1, so which is going to be here between 0 and pi square root of 1 minus 2 cosine square x minus 1 dx, which is the same thing between 0 and pi square root of 1 minus 2 cosine square x plus 1 dx. So here I will have 2, so square root of 2 minus 2 cosine square x dx. I take 2 as common factor, so it's going to be square root of 2 times 1 minus cosine square x dx, so 2 I can put it out, so it's going to be square root of 2, and 1 minus cosine square is sine square, so I will have 0 pi square root of sine square x dx. So here I will have absolute value, so it's going to be between 0 and pi square absolute value of sine x dx, and we know that absolute value is always sine is always positive between 0 and pi. We just see it. So it's going to be square root of 2 integral between 0 and pi sine x dx, which is going to be minus cosine. So now I'm not going to make the mistake. So here is going to be minus cosine of x, 0 and pi, and we were done. So it's going to be square root of 2. So here is going to be minus cosine of pi plus cosine of 0, which is going to be 1 plus 1. Going to be 2 square root of 2, and this will be your answer. Is that clear? Now for last question here. So here if I use u is x squared minus 5, that means my du will be 2x dx. So I don't have the 2, but I can create my 2, so it's going to be half 2x secant x squared minus 5 dx. So this is my du, so it's going to be half secant of u du, and we already know that secant is ln, so it's going to be half ln absolute value of secant of u plus tangent of u plus c. Then substitute by its value, which is x squared minus 5, then we'll be done. So ln of secant of x squared minus 5 plus tangent of x squared minus 5 absolute value plus c. So here I do the same thing here. So I use u is my e theta plus 1, so du will be e theta d theta. So those two are my du, so I will end up having cosecant u du, and we know that the integral derivative of cosecant is minus ln absolute value of cosecant u cotangent u, so plus cotangent u. So this is the here the same thing. If I have minus ln of absolute value of cosecant u plus cotangent u plus c. So like I say, if you want to integrate this, you multiply both sides, the numerator and denominator, by this expression. So you're gonna have on the top the numerator. So if I do it here, if I have cosecant u times by cosecant u plus cosecant u plus cotangent u, and here I times by cosecant u plus cotangent u. So what we end up having here is cosecant square u plus cosecant u cotan u. So I don't have space here. I'll try to write it down very small. So cotan u over, we have cosecant u plus cotan u. So the derivative of cotangent is negative cosecant. So this is the same thing if I have minus cotangent u prime, and here is plus minus cosecant u prime. So if I put out the minus, look what I will have. I will have minus, and I will have cotangent u plus cosecant u prime over cosecant u plus cotangent u. As you see here, if this is my w, so I will have minus w prime over w, and this is ln. So that's the idea we use to integrate that type of expression. So that's the idea behind. Okay, so here now I substitute back my expression, which is e theta plus 1, so it's going to be minus ln cosecant e theta plus 1 plus cotangent of e theta plus 1 plus value plus c, and this will be your final answer. So I hope you understand what we did today. So see you for the next coming review, because this review will be 3 videos, so we'll post the second one inshallah sooner. So thank you for watching this review, and please, if you have any comment, do so. It will help me improve my way of teaching and explaining. So Assalamu alaikum.